All this hard SAT. Can you still Can you solve this hard SAT geometry question? Point O is the center of the circle above, and the measure of angle OAB is 30 degrees. If the length of OC is 18, what is the length of arc AB? So first, let's enhance this image. We're going to have it right here. Let's hope what we know. First, we know OC is 18, and that's the same as the radius. And we know a length of an angle, which can be 30 degrees. Now let's figure out what we can from this image. AO and BO both come from the ends of the circle to the center, meaning these are also radius, and they can have a measurement of 18. Now we have that. And what we can see is this triangle formed is actually an isosceles triangle, meaning that two angles must be the same, which can be the two acute angles of 30 degrees. Now that we have this down, let's remember the angles of a triangle. The triangle's interior angles is 180 degrees, in which you can then form an equation where 180 degrees equals 30 degrees plus 30 degrees plus the unknown angle O degrees. And from this, we can figure out that this angle is 120. Well, when you look at our answers, all our answers are in radians. So we need to set up a unit conversion where we're going to have 120 degrees and we're going to convert it to radians. In 1 radian, there's 180 degrees. So when you do the multiplication and cross out the units, you're going to get 2 over 3, don't forget the radians, or the pi. And you're going to get 2 over 3 pi. And now we need to figure out the length of the arc, in which we're just going to multiply this angle by 18, by the radius, in which we're going to see that our answer is 12 pi. Can you solve this hard SAT geometry problem? Point O is the center of the circle above, and the measure of angle OAB is 30 degrees. If the length of OC is 18, what is the length of arc AB? First, let's enhance this image, and we're going to write down everything we know. We know OC is 18, and we also know that it comes from the center circle O, meaning it's also a radius. Then we're given an angle measurement, which we're going to label right there at 30 degrees. Now let's figure out what we can from this image. AO and BO are both lines drawn from the ends of the circle to the center, meaning these are both radii, in which they can have a measurement of 18. Now we can see that the triangle formed is actually an isosceles triangle, which means two angles must be in common, which are going to be the acute angles, which are going to be 30 degrees. So you can write a 30 degrees in OBA angle. Now, remember that the triangle's interior angles are 180 degrees, and we can set up an equation now, where 180 degrees equals 30 degrees plus this unknown angle AOB. Now we can solve for this unknown angle as to be 120. Let's label it on our diagram. Now our diagram for the most part is complete, but when we look at our answer choices, none of the answers are in degrees. We need to convert to radians. So we set up a unit conversion, in which we're going to be converting to radians, from degrees to radians. So we have our 120 degrees, and we multiply it by a radian, and in 1 radian, there's 180 degrees. So when you do the multiplication, you get 2/3 pi radians. And now we're not done yet, because none of the answers align with that. We actually need to multiply this by the radius of 18, which we're going to see that our answer is going to end up being 12 pi.